Okay, here we go, launch of class. Big packet called 4 Fitch-style proofs. Let's do it. The first two are quite challenging, but actually just as hard as the hardest problems from the previous packet. 3 is a kind of wild challenge, and 4 is really just some calculus done in the Fitch style. Okay, we begin. I don't even think I need to look at this. Here we go. We have this theorem that we're trying to prove. For all y, there exists an x. Again, I'll use punched because I like that. Suppose that for all y, there is an x that didn't punch y. So everyone has someone that didn't punch them. And this says that there exists someone that does not exist someone that everybody punches. It's not the case that there exists someone that everybody punches. Oh, sure. So if there does not exist someone that everybody punches, then for every single person there must exist someone that didn't punch them, which is exactly what this says. Okay. So I 100% understand this. Let's just do it. I'm going to just try to write extremely small and fit this on to one board. New board coming very soon. Okay, I'm going to do this as fast as I possibly can. Let's go with maybe minimal commentary. So this is an if and only if proof, so I begin. For all y, there exists an x, not pxy. Chop. Well, from this I need to prove a negation, so I am going to do a proof by contradiction. So here I shall assume that there exists a y such that for all x, pxy, and then I will get a contradiction. Okay, well, if there exists a y, let me temporarily name that person. Let me name them B. And B is just my name for the person that I know exists by virtue of line 2. And therefore, what do I know about this person B? I know that for all x, pxb. And, however, line 1 tells me some contrary news. So I basically just stick B in for line 1. I'm not even explaining why I know how to do this. I just know how to do this because I'm just a Fitch-style proof master. So I just stick in the B. I mean, okay. The real reason is, right, the reason why I did line 1 is because, duh, I'm doing a biconditional proof. The reason I did line 2 is because, duh, I'm doing a proof by contradiction because the thing I'm trying to prove is a negation. Now I have existential information, so I can't make any progress on that unless I call that person something, so I choose to call them B. And, well, what does 3 say? The 3 says that everybody punched B, and yet it's line 1 that tells me that everyone has someone that didn't punch them. So by sticking B in for Y, I get immediately contradictory information. This on the one hand says everybody punched B, but this says there exists someone who didn't punch B. Okay, well, let's call that person something, say A. And what do I know about this special person? I know that they didn't punch B. And yet, line 3 says everyone punched B. And so I am sacrificing clarity here for writing really small. P-A-B. That is a contradiction. And then that contradiction is just going to hold out in the main body of the proof, and then again, and then again. This is a brand new marker and it's already dying. It's making me really sad. So there does not exist a y such that for all x, p, x, y. And what's the justification? Let's see, what's the first step I need to justify? This one. This is universal elim 1. This line 4, here in line 6, this is universal elim 3, I guess. Yeah, universal elim 3, that's how I got that. This is an intro 5 and 6, 5 comma 6. This is bottom intro 7. Then this line 9 comes from doing this existential elim, specifically I considered the statement in line 4, and it's an existential statement, and by temporarily naming that person A, in lines 5 through 8, I arrived at a conclusion, that conclusion being bottom. This is line 9 I'm talking about now. So in fact, bottom holds. Well, I reached the conclusion in line 8, so my of that subproof, and so I now bring it back out to the main body of the proof. And now in line 10, the conclusion of line 10 is a result of starting with an existential statement in line 2, exploring it in lines 3 through 9, and concluding in line 9 a contradiction, so that contradiction just must hold. And then this is this negation intro 2 through 10. Okay, if you're finding this explanation insufficient, then you should go back and watch some of the older videos on, say, proof 42, 43, and 45, and 46 maybe, where I go into extreme detail on this kind of thing. For this one, let's just not do that. I'll assume some level of expertise or something like that, maybe. Okay, let's do the converse, which I think is just much harder. And yeah, just doing a kind of quick line count. Yeah, it is just much harder. Okay, so right on track. Now in line 12, I turn around and go the other way. So now it's not there exists a y for all x, p, x, y. And I have to get to this. Okay, well, there's only one No. You can just do a universal proof, right? Yeah. Yeah, okay, actually, so this problem number 1 is maybe not that hard because, well, let's see. So if I want to go from here to here, I need to prove something about all b's. So I guess I do want to do this from the inside out. So let's see. I'm gonna leave sort of one spot left over for my kind of final line or something like that, or maybe I won't even bother rewriting the final line because I've written it on the top of the board. But the conclusion of the second half of this proof, of course, is going to be that for all y there exists an x such that not pxy. Okay? And yeah, it's a terrible board. Okay, what's the reason for this? Or how am I going to prove this universal statement? There's only one good way, and that's to start up here and take an arbitrary b about which I assume nothing at all, and conclude way down here that there exists someone who didn't punch B. Chop, chop. Okay, so if I can prove that there exists someone that didn't punch B, then it will be the case that for everybody there is someone that didn't punch them. Okay, how am I going to prove that there exists someone that didn't punch B? I think my only choice now is to do this by contradiction. So I guess this is kind of hard, because I need to do this by contradiction. I have to sort of see that that's the only way. So negation, negation, there exists an x, not p of xb. In other words, my only path forward here is to start up here in line 13, assuming the negation of that, so that suppose that there does not exist an x such that not p x b cha cha, and get a bottom, and then that will entitle me to conclude the double negation. I'll eliminate that double negation, and then I'll conclude the universal proof. Okay, now, man, things look hard now, but they're not. Here's where I have innovated this year and how to teach this. How I think one should proceed next. Either you're just so good at these that you just know what to do, but if that's not the case, then there's like a trick. And it's not even a trick, it's just kind of common sense, and the common sense is to ask yourself, what is this line 13 really? Now, okay, this example is simple enough that I can just sound it out, so maybe that in some ways that's superior, because what does 12 say? 12 says that it does not exist, so I have to show how 12 and 13 together lead to a contradiction, which they must. Well, they do intuitively lead to a contradiction, 12 and 13, because 12 says there is someone that 12 says there's not someone that everybody punched. Yeah. There's not someone that everybody punched. And yet, no one, it is not someone that didn't punch B. So if no one failed to punch B, then in fact line 13 is just screaming everyone punched B. In fact, just by applying the sort of De Morgan law in your head, distributing that negation through the existential quantifier, if I say that it's not the case that there is someone that didn't punch B, that's just saying everyone punched B. And yet, it can't be the case that everyone punched B, because line 12 is saying that there's not someone that everybody punched. Okay, and so the contradiction is going to come from B being a person that everybody punched, and line 12 saying there can be no such person. In other words, working outside in, I know that I'm going to prove that there exists a y such that for all x, pxy. And I will add that on to line 13, and yeah. So that's what I need to prove, that there is this person that didn't punch, that there is a person that everybody didn't punch. Hold on, I got lost for a second. Because this is, that's not what I meant to write there. Not, and there does not exist. This was just, I just wrote the wrong thing. I just kind of zoned out for a minute, sorry. It's line 12, it's that there exists someone that everybody punched, but line 12 says there does not exist someone that everybody punched. Okay, there we go, back on track. And how am I going to prove that there exists someone that everybody punched? Well, in fact, it's true that everybody punched B. And that's ultimately what line 13 says, that really everyone punched B. And how can I show that everyone punched B? Well, I guess I do a, this one is just different enough, I guess, to be kind of exciting. This should be a B here. So I take an arbitrary A, and about that arbitrary A, I'm going to prove that A punched B. Okay, well, if from nothing I can prove that A punched B, then actually everybody punched B. And if everybody punched B, then there is someone that everybody punched. But if there's someone that everybody punched, that contradicts line 12 that says if there's not someone that everybody punched. Okay, how am I going to prove that A punched B? Well, I can think of only one good way, and that is by contradiction. So not P, A, B. I might have been too aggressive on my spacing. I think I'm done, basically, because what I'm going to do right now in line 14 is assume that A didn't punch B. And since that's going to lead to a contradiction, it's going to turn out that A did punch B. And why do I know that, what's wrong with the assumption that A didn't punch B? Because if A didn't punch B, then, and now I'll begin my notations, then it means that there exists an X that didn't punch B. Reason existential intro 14. A didn't punch B, so there exists someone that didn't punch B, and yet I have that on the one hand there exists someone that didn't punch B by line 15, and on the other hand there does not exist someone that didn't punch B by virtue of line 13. Together those make a contradiction, and I am now done, I think, I hope. 24, 25, 26, and 27. Whew. Okay, so what's the reason for this? And intro. 13 and 15, or 15 and 13, sometimes I read it that way. This is bottom intro 16. Here I did a negation intro 14 through 17. Here a negation elim 18. Here I started with nothing and got that A punched B. So by universal intro, everybody punched B. In line 20, I have that everyone punched B. So in line 21, there must exist someone that everyone punched. But that is a contradiction with line 12, which started this whole thing off. So 22 and 12 lead to a contradiction. So bottom intro 22, and now I started way up there in line 13 with something, so, and it led to a bottom, so I stick a knot in front of that 13 through 23, eliminate that double negation in line 24, and there is my statement. Notice that I started with nothing and proved that there's someone that didn't punch B. Sorry, I started with nothing and proved that there's someone that didn't punch B, so it must be the case that for everyone there's someone that didn't punch them. So universal intro 13 through 25. Good. This was just, and then the final line will be biconditional intro, which I'm not going to rewrite because I'm lazy. 1 through 11 and 12 through 26. 12 through 26. Okay, good. How long did that take? Woo, nice tight 17 minutes. For me, that's like nothing. I found this, I don't know, easy. Hopefully you found it easy too. If you're finding it easy, that's because it's easy to do things over again that you've done already. It's actually quite hard, but you know, once you do something for the second, third, fourth time, it becomes a lot easier. So I thought this was easier than 45. But actually, I think it just is more or less exactly 45. Perhaps it's a little simpler. I don't know. Okay, good. That was number 1. Let's go straight to number 2. I guess I could have paused this video in between proofs, but too bad. Okay, so number 2. What is it? Well, here we go. It's just another big old proof. The statement is, so what the thing that I need to prove is, it's not the case that for all x there exists a y such that p of x implies q of y implies that there exists an x such that for all y, p of x and not q of y. Okay, this is going to be maybe harder to make sense of. Oh yeah, this is just like really hard. Notice, by the way, this arrow is going in one direction only, so I only need to go kind of from here to here. I think this is actually biconditionally valid. But because if I distribute this negation through using the quantifier De Morgan laws, I get there exists an x such that for all y, and then it pops in here, the negation of not p or q would be p and not q. So yeah, in fact, you could do it in both directions, but it's already 29 lines. Just going in this direction, I think this is the hard direction, so I said, you know, just do this. Okay, so if you can do this, I mean, you can really kind of do anything now. Let's go. Okay, this proof's not going to write itself. So, we begin in line 1 with, again, writing small, that there is not the case that for all x, there exists a y such that p of x arrow q of y. Cha, 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 cha. Okay, and way down here, I will have my conclusion, which is that, down here, I will conclude that there exists an x such that for all y, p of x and not q of y. Okay, I haven't looked at my paper or anything, so I'm just going to kind of wing this, but I can tell you for sure now that I have to do this by contradiction. Of course, there's no other way. So let's just get started with that. Oh yeah. So way up here in line 2, I suppose that it's not the case that there exists an x such that for all y, p of x and not q of y. And down here I will get a bottom, and then I will thus conclude that not there exists an x, p of x and not q of y. And that will be great. Okay. Good. Well, I have to kind of coax a contradiction somehow out of line 1 and 2. Man, that's going to be hard. But maybe not, because I've done this exact kind of problem now many times before, and I know that the contradiction is going to come from either proving the negation of line 1 or the negation of line 2. And it's just going to be the negation of line 1, right? Because it's the negation of line 2 that I'm in the middle of trying to prove right now, and it's the fact that I couldn't prove this which led me to do a proof by contradiction in the first place. So with that kind of idea, then I'm just going to be confident that the contradiction is going to be for all x, there exists a y such that p of x arrow q of y and the negation of that, in other words, line 1. So not for all x, there exists a y, p of x implies q of y. Okay, good. Well, that means that I know sort of what I need to do. I need to prove this universal statement. And to prove this universal statement, I have a plan for that. And the plan for that is to do a universal proof. So up here I shall assume an arbitrary object A, and what I'm going to prove about that arbitrary object A is that there exists a y such that p of A arrow q of y. Okay. Great. Okay. Well, good. Going to my standard example, which is a dumb example of letting p mean pretty and q be meaning quiet. What this says is that there exists someone that gets quiet when A is pretty. So if A is pretty, then this person Y gets quiet. There exists such a person. Okay, that gets pretty. That gets quiet if A is pretty. Okay, how am I going to prove that? Only one way, by contradiction. So right here, I'm going to miss you, old crappy terrible board that I hate. With lots of annoying scratches in it. I'm going to do this by contradiction. So over here in line 3, I suppose that it's not the case that there exists a y such that p of A implies q of y. And then down here I will conclude bottom, in which case not there exists a y, p of A implies q of y. Okay, so I don't want to mess up, but I also don't want to peek because I really do want to see if this is just easy for someone who knows as much as I do about this. Now we're at the hard part. It's very unclear what to do now. This is essentially like just another version of 46, to be totally honest. This is just the hard the hard half of 46, just kind of repeated with some slight changes, which was the hardest problem in the original packet. So, okay, basically where are we right now? Not in a good place. I need to get a contradiction, but I need to get it from lines 1, 2, and 3. And they're all negations. And so the moment of truth is now. How do I get this contradiction? Well, one way to, I kind of just know what to do. But one thing you could do is to take a look at this proposition which you're holding in your hands. This, there does not exist a y such that P of A implies Q of Y proposition. Okay, so that's a proposition, right? Well, what's up with that? What can I say about that? Well, you know, we are sort of free to rewrite this conditional as, you know, not P of A or Q of Y. Okay. And let me just kind of off script, so to speak, apply the De Morgan laws to the quantifiers. What does it say? It says that for all y, flipping the quantifier, then it's not the case that not P of A or Q of Y. That's just the De Morgan laws for the quantifiers. And then, of course, distributing this through gives me not P of A, so P of A and not Q of Y. And, well, look, that just flatly contradicts line 2. Because here we have the statement that for every single person, A is pretty and that person is not quiet. Okay? Whereas line 2 says there is not such a person. Line 2 says there is not such a person, X, such that they're pretty and everybody is not quiet. And so you should feel that this line 3 is a few logical steps away. It is in fact logically equivalent to, this is maybe in your mind, it is logically equivalent, this line 3, to a statement which is a special case of a statement which just contradicts line 2. Okay, and now that's it. I'm just done, right? I know how this contradiction is going to come. It's going to come from contradicting line 2. In other words, I'm going to prove that there exists an X such that for all Y, P of X and not Q of Y. And line 2. And that is going to be the source of my contradiction. P of X and not Q of Y. And, of course, this strategy assumes that I can prove that there exists an X such that for all Y, P of X and not Q of Y. And I can prove that because, in fact, the person is just A. In other words, I'm going to prove that for all Y, P of A and not Q of Y. And that's just true. Because we just showed that this thing right here, which will enable me to finish off the proof, is just logically equivalent to line 3. So now I just have to get from 3 to here. And how am I going to get from 3 to there? Well, I just know what to do next because this is a universal. And so I shall prove for an arbitrary B, I shall show sort of from nothing that P of A and not Q of B. And then we'll conclude that that must be true for every Y. Okay, and there it is. Now I just have to get from line 3 to here, and that doesn't sound too hard. Yeah, it doesn't sound too hard because I guess I'll just prove the negation. So I'll prove, let's see, is this the way to do it? Hold on, I lost track of things for a second. Yeah, so I need to show that this is true, and that needs to come from line 3. Okay, so yeah. So So this is a little bit smooth what I'm going to do now, but I think the smoothest way to prove this, one second, am I just going to do a little proof by contradiction right now? I think so. So I only have to do this once. Yeah. So I think what I'm going to do right now is just wrap all this in one more proof by contradiction, because then it's just going to be fewer lines that way. So suppose it's not true that P of A and not Q of B. Hold on, this might be wrong. This might be wrong. No, I think it's just right. Because I'm going to suppose P of A, and then I'm going to do not Q. Yeah, I think this will, I don't know if this is the best way, but this is a way. So not, is this what I did on my paper? No, my paper I did something kind of like better. Yeah, this is, I take it back. This is a way, but this is not the coolest way. The coolest way is to just prove, because line 3 is a conditional, okay, yeah, so here's what I'm going to do. This contradiction, no, I want, oops, I erased the thing that I wanted. I want, oh man, I did do it by contradiction. Okay, whoops. Alright, wasted 1 minute of your life. I shouldn't have doubted myself. So right here, I am going to assume that it's not the case that P of A and not Q of B, and I will get a contradiction which will enable me to conclude not P of A and not Q of B. And hopefully I have enough room for this. So contradiction coming right there. And then I'll be done with this problem. Okay, where does this contradiction going to come from? Well, propositionally now, I can prove P of A arrow Q of B. And so, I'm going to do that. So assume P of A. Now, prove Q of B. Well, I'm going to do that by contradiction also. So assume not Q of B. But now this doesn't work, because now I have P of A and Q of B. Whoa, guys, it's logic. And Q of B. And of course that contradicts line 4. So now I get P of A and Q of B and not P of A and not Q of B. I think I missed a not in here. Oh man, I missed nots in both of these places. Good thing I'm being careful. Not Q of B, not Q of B. Okay, P of A, I hope that looks good at the camera. Good. So in other words, I just and these, maybe I'll just start with my notations right now. What's line 7? It is and intro, because this is my first line that isn't an assumption, believe it or not, line freaking 7 of this proof. And intro 5 and 6. So I stick lines 5 and 6 together, which gives me that conjunction. I and that conjunction in line 7 together with line 4, so 7, 4, that is a bottom. And the reason is bottom intro 8. Well, that means that my assumption in 6 is wrong, so that gives me not Q of B, which gives me Q of B, which gives me P of A implies Q of B. And now I think I need 2 more lines in here, right? Which, no, shit, back out here it gives me that. Sorry, I forgot to dedent. So that's 12, 13, 14. 12 is the fact that I just did a conditional proof. Now I say that there therefore exists a y such that P of A implies Q of B. This is quite hard. And finally, in line 14, so I have just enough space, and that together with line 3, which is the negation of it. So there does not exist a y such that P of A arrow Q of B. Okay, and there we go. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and then my final line 29 is just a restatement of the thing on the top. Okay, let's finish the notations. What happened here? I assumed something in 6 I got a bottom, so that's negation intro 6 through 9. This is negation elim 10. This is arrow intro 5 through 11. This is an existential intro 12. This is and intro 13 and 3. This is bottom intro 14. And then here's what happened is I assumed something in line 4, and that led to a bottom in line 15. So the whole thing was a proof by contradiction. Now I conclude the opposite, then I eliminate the double negation, and then I started with nothing and proved some fact about B. So in fact that thing holds for all y, so that's a 4 through 17. And here I just assert existential intro 18. And here we have and intro then 19, and I guess that's 2. Yep. So that's bottom intro 20, and then this whole thing was a giant proof by contradiction. So that's negation intro 3 through 21, negation elim 22, and I started a gigantic proof way up with A, just above line 3, and so 3 through 23, I conclude something about A, so that must be true for all numbers. I and that together, that line 24, with line 1, which gives me a bottom. And taking this out to the bitter end, this is negation intro. This whole thing was in fact a gigantic proof by contradiction, 1 through 26. So I eliminate the double negation in line 27, and it's all done. The final line, which I won't rewrite, is just arrow intro, not biconditional. Although the biconditional is true. Arrow intro 1. Uh-oh. Now I'm worried I made some mistake. It's not 1 through 26, it should be 2 through 26. Just like lying on the ground to get a better view of things. Yep. Arrow intro 1 to 28. Okay, woo, good. If you can do this, you can do anything except maybe number 3, which is so hard. I'll pause the video. Okay, we are back. We are going to prove this crazy statement number 3. This is like by far the most fun Fitch-style proof we've done the entire year so far, I think, because it involves kind of creativity, understanding. It is just a wild ride. I almost, I can't decide whether to do the proof for you or to just give you a big hint. And I think the first time I ever solved this problem, I did it just by kind of grinding it out with just resting on the confidence I have in my own abilities to just do Fitch-style proofs and kind of doing what comes next in a way that makes sense. But the better way to do this proof is to just have a full understanding of what it says and what it means, and to sort of reason the entire thing out for yourself. And then just the proof just goes through kind of slowly the precise logic that you've already kind of thought through. So let's do it that way. All right, what is this saying? Well, first of all, this entire statement is a negation. That's the main connector. So this thing that we're proving is a proof that there can't be some person X. Okay, so of course this is going to be a proof by contradiction. The very first thing we're going to do is to assert that there is some person X, and we're going to show that this is kind of impossible. All right, so what is it about this person X which is, what property does this person X have which is impossible, in fact, for X to have? Okay, well, for all Y, R, Y, X, if and only if, there does not exist a Z such that R, Y, Z, and R, Z, Y. That is just weird. There are now sort of 3 quantifiers, and they're switching, so cognitively this is quite a load. So in order to make this palatable, we need to give some kind of meaning to R. So R is a predicate, a binary predicate. Some people just say relation. And, okay, well, what can R mean? I think a good default is loves. I like loves because it's a binary relation, and it seems to get your brain kind of pumping with thoughts. People seem to care about loving or being loved, but also it's nice in that it is not symmetric. You can easily love someone and they don't love you back, for example, so it's a nice kind of generic, and you can love multiple people and multiple people can love you, so it's a nice kind of generic relation. Okay, so let's let R be the loves relation. So now we're getting somewhere. Now there's some object X, and somehow it's impossible for the following to be true. For everybody, if you love this person X, okay, well now we just need to pick a name. We gotta call this person something. Okay, let's just, well, I can't decide whether to be funny or just be kind of lame. I guess I'll just be lame. And the lame thing to do now is to just say, okay, let's just call this person X something like A. Okay, so now, this is off script now. I'm just kind of reasoning out what's going on here. What's going on here is that there's this special person A, and here's what's true about A. What's true about A is, for every single person in the entire world, if R, Y, A, then not there exists a Z, R, Y, Z, and R, Z, Y. Okay, what is this saying, and why does this lead to a contradiction is kind of the question. What's wrong with this? Well, here's what this says. For every person in the entire world, if you love A, then there does not exist a person who you love and who loves you back. That's what this second thing says, right? This says it's not the case that there exists a Z such that R, Y, Z, and R, Z, Y. So R, Y, Z, and R, Z, Y, this says like, Y loves Z and Z loves Y back. So what this says is, this magical, mysterious person A is such that being in love with them is like some kind of curse or something, right? For every single, there's this special person A, and for every single person in the entire world, being in love with that person A provides some kind of a curse. And the curse is, if you're in love with that person, then you are not, there does not exist a person that you love and who loves you back. So if you are in love with this person A, then you are not in a mutually loving relationship. Okay. Alright, so I still don't see where the contradiction's coming from, but I have a sort of a more feel for this problem now. There's some special person A, and for every single person in the entire world, if you love A, then you're not in a mutually loving relationship. Okay, well now the obvious question is, does A love himself? Oh, their self. Well, Oh, and before I get to that, I should say that it's because it's biconditional, it works in both directions, right? If you love A, then you're not in a mutually loving relationship. And if you're not in a mutually loving relationship, then you do love A. So A is some kind of, not only is A some kind of witch, such that if you're in love with A, you are not in a mutually loving relationship. But if you're not in a mutually loving relationship, then you're obligated to be in love with A. And by the way, if you are in a mutually loving relationship, then, based on the way the biconditional works, then you're not in love with A. And vice versa. If you're not in love with A, then you are in a mutually loving relationship. Okay, does A love their self? Well, just suppose for the moment that that A did love himself. Well, if A loved himself, then what would we know? We would know that A is not in a mutually loving relationship. But A is in a mutually loving relationship with himself. Okay, so this leads to a contradiction. The supposition that A loves himself is impossible because A is subject to his own witchy powers, such that if you're in love with A, you're not in a mutually loving relationship. But everyone who loves themselves is in a mutually loving relationship with themselves. Okay, so in fact, it's impossible for A to love himself. So, I now know, this is all just informal logic, I now know that A doesn't love himself. A doesn't love himself. But if A doesn't love himself, then, based on what we've just been talking about, then it means, if that's false, then that has to be false also. So, that means there is somebody that A is in a mutually loving relationship with. Because that's what it means to be in, sorry, one second. If A doesn't love himself, then, so we sort of stuck A in for Y here, well then, A is in a mutually loving relationship. But if A is in a mutually loving relationship, who can A be in that mutually loving relationship with? Who is this poor person that is in a mutually loving relationship with this witch A? Well, let's call that person like B or something. But now we have a problem. Because if A loves B and B loves A, this cannot be. Because the very notion of loving A means that you are cursed and you are not in a mutually loving relationship. So it's impossible to be in a mutually loving relationship with this person A. Because being in love with them implies that you're not in a mutually loving relationship. Okay, I think I said that right. Rather, being in a mutually loving relationship with A is impossible. Because if you're in a mutually loving relationship with A, then you don't love A. That's kind of maybe the way of putting it. Okay, this shows why this whole thing is impossible, and such a witch can in fact not exist. Alright, and if you know something about this, this is just like basically like Russell's paradox in a kind of twisted form. Alright, if you followed that whole thing, what you should do right now is turn off this video and just do this proof yourself. And just, stop watching. I'm not going to do number 4 because it's just a Fitch-style proof of a epsilon delta proof. So this will be the last video of this. This will be the last proof of this video. So if you want to try it yourself, you really should because it's really kind of fun. If you pause the video and then keep watching, sorry, pause the video, try it yourself, and then maybe come back if you're really stuck or something. But anyway, I'm going to do it right now, and I'm going to do it this kind of smooth way that it's not super intuitive, but I think is the shortest way to do it, based on using some Fitch-style proof skill. So okay, all right, let's just kind of do this and then move on. So what are we going to do? We're going to assume that there does not exist an X. No, we're going to assume that there does exist an X, such that for all Y, R, Y, X, if and only if there does not exist a Z, such that R, Y, Z, and R, C, Y. Cha-cha-cha, cha-cha-cha. Okay, great. And then way down here, I will have a contradiction. So I'll throw in a bottom, and then I'll have, I think I'll just write this because, you know, I got a nice marker now, so I'm in a better mood. R, Y, X, if then, only if there does not exist a Z, such that R, Y, Z, and R, Z, Y. Close the brackets, close the other brackets. Okay, so yeah, this whole thing is a giant proof by contradiction, like I said. And the very first thing you're going to do is just sort of name that person. And so we're going to name this person A. And what is the key fact about A is, like I said, A is some kind of witch. If you are in love with A, then you are not in a mutually loving relationship, and if you're not in a mutually loving relationship, then you are in love with A. And if I can show that this leads to a contradiction, then there will be my contradiction. Okay, so like I was saying before, yeah, so the tempting thing to do right now is to, what did I do on my paper? Oh yeah. The tempting thing to do right now is to stick A in right here. This would follow along the lines of what I was talking about. If I stick an A in here right now, and I suppose that RAA, then I'll get that A is not in a mutually loving relationship. But actually, then I just have to end up going back and doing all this extra work, because once I know that I have to do all this crap with biconditional stuff, it's kind of annoying. So actually, the smoothest thing to do is to just prove that A is not in a mutually loving relationship. Am I doing this right? I guess it doesn't matter where you do it, right? Yeah. No, I sort of take it back. I do want to stick this. This is slightly different than what's on my paper, but I do want to stick an A in here right now. So I do get RAA. I hope this is right. If and only if there does not exist a Z such that RAZ and RZA. Chop, 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 chop. Okay, so that's this is basically so far. This is exactly what we were doing in our sort of talk out. If A loves himself, then A is not in a mutually loving relationship. And now I have to what I did in my talk out version was I said suppose A loves himself, then he's not in a mutually loving relationship, but he is in a mutually loving relationship. So that's just kind of like a problem. So A doesn't love himself. But it's actually easier to just prove. I'm cheating so hard. Okay. But it's easier to just suppose that A is in a mutually loving relationship. What is on my paper? No, it's to suppose A is not in a mutually loving relationship and show how that leads to... Oh, okay, I see. So, okay, yeah. So suppose now that A is, it really doesn't matter which way you do this. Everything is just going to work now, but some things are going to work better than others as far as backtracking and stuff. So now I'm just going to suppose the right-hand side of line 3. So suppose that it's not the case that there exists a Z such as RAZ and RZA. Well, this is just immediately impossible because by biconditional intro, we get that A loves himself. Reason by, well, I should notate as I go, I guess. This is universal elim 2. This is biconditional elim, been a while since we've done one of those, 3, 4. In other words, there's a rule that says if you have a biconditional and you have the right member, then you just get the left member. That's biconditional elim. Okay, but of course that's impossible because in fact, if A loves himself, then A is in a mutually loving relationship with himself. So this is just going to lead immediately to a contradiction. Okay, and so how do we do this? This part is the one that's kind of weird, and I guess it depends on how what your style is, whether you want to add in like an extra line or something. At this particular mood I'm in, I'm going to just throw in an extra line where I state line 5 again, and my reason is read. And then I will end these two together. So this is the sort of technical flourish that you have to have confidence in yourself is legitimate because, hey, why not? And also it's like kind of just what you need to do next, right? This is the intro 5, 6, and you could easily just go straight from 5 to 7 by just adding 5 to itself. I don't see any reason why not, but here I just did it in 2 lines. Okay, why do I want to make this weird statement that A loves A and A loves A? Because that can't be. Now what I'm going to do is I'm going to just go straight to, I'm going to existentially introduce Z, R, A, Z, and R, Z, A. Cha. In other words, reason existential intro. In other words, this is also kind of a crazy little technical move here, right? But of course, right, to go from line 7 to line 8, what are you doing, right? A loves A, and A loves A. So no, I shouldn't say it that way. I should say A loves something, and that something loves A, so therefore there exists something that A loves and who loves A back. Okay, if you think about that for a minute, you'll realize that's just absolutely legit. And that's also just a contradiction now with line 4. So what we have is, on the one hand, there is someone that is in a mutually loving relationship with A, but it is line 4 which says there is not someone who is in a mutually loving relationship with 4. And this is and intro 8 and 4. Okay, the advantage of doing it this way is that I now have a bottom, and then I can just go straight to not there exists a Z, R, A, Z, and R, Z, A. In other words, and then therefore to that there exists a Z, such that R, A, Z, and R, Z, A. This is striking me as kind of a confusing way of doing it. In fact, I'm confusing myself, but I guess this is just shorter than doing it some other way. Here we have bottom intro 9. Hopefully the individual steps all make sense. In other words, I assume that A is not in a mutually loving relationship, and really looking back at line 3 is the first moment I had to sort of make a decision. And I chose to assume the right conjunct, that A is not in a mutually loving relationship. But if A is not in a mutually loving relationship, then A loves A. But if A loves A, then A is in a mutually loving relationship with himself. Therefore, that's impossible, and so I just get immediately that A is in a mutually loving relationship. Therefore, sort of bypassing the fact that A doesn't love himself, which is true. Also, okay. Anyway, what is this? This is negation intro 4 through 10. This is negation elim 11. And now ready to do the second half of the proof. Because it's just impossible, as we already discussed, for A to be in a mutually loving relationship. Why? Because the person that A is in a mutually loving relationship with loves A, but then isn't in the mutually loving relationship. This is amazing. So, what do we do now? We start a existential elim with a new letter, B. What do I know about B? I know that R, A, B, and R, B, A. It's possible I'm not writing small enough. okay, and I'm going to show that this leads to a bottom, and therefore I'll have my bottom. Okay, why does this lead to a bottom? Because now I say, okay, well, yeah. Because I have RBA. I think this is what I want to do. And then I stick a B in, go back to line 2, and stick a B in there, and this gives me RBA if and only if there does not exist a Z such that RBA and R sorry, what happened? I'm sticking a B into line, no, RBZ and RZB. Let me just double check that for a second. But I think that's right. What am I doing? I just stick a B in, yep, for Y in line 2. Yeah, okay. So again, what's going on? I know I have now in line 12 that A is in a mutually loving relationship. Let's call that person B that A is in a mutually loving relationship with. So A loves B and B loves A. But if B loves A, then reusing the defining property of A in line 2, I now get that there does not exist a Z that B is in a mutually loving relationship with. And yet, Z, B. And yet, why am I having so much trouble with this? Don't I have, what have I done? RBA, BA, zoom, zoom, zoom. Yeah, okay. So what's wrong with that? Oh, yeah. Yeah, there's this sort of this like technical problem here, which is that technically, well, I guess I just have to do something now. What do? I want to, first of all, I think I want to notate as I go. So what is this? This just came from and elim 13. This proof's kind of hard. And elim 13. This is universal elim 2. This is biconditional elim 15 and 14. Okay, so where is the contradiction coming from? The contradiction is coming from the combination of line 13 and 16. So I need to do one more thing. I need to take out line, I need to write kind of small here maybe. So I need to take out from line 13 RAB. Then I need to add them back together in the opposite order. Because I really need this to say RBA and RAB. Then I need to, in line 19, say that therefore there exists a Z such that RBZ, that wasn't so hard, and RZB. Close, close, close. And then line 20 is just exactly 19 and 16 together. Yeah. Whoa. So I didn't exactly run out of room, but got a little smushed. And RZB cha-cha-cha. And not the case that there exists a Z such that RBZ and RZB cha-cha-cha-cha. Okay, so, yeah. Where did all this come from? Line 17 just came from and elim 13. Line 18 came from and intro 14, 17. If we're going in order. And finally, this is existential intro 18. And then this guy over here is and intro 19 and 16. And this is bottom intro 20. And now, of course, this is line 22. What happened is that I took line 12, which asserted the existence of some person, and I explored that by temporarily naming it B in lines 13 through 21. And I reached a bottom, so that bottom just holds. And then this entire gigantic proof was also an existential elim of line 1. So I explored that in lines 2 through 22. And anyway, I got a bottom. So in line 24, by negation intro 1 through 23, this is contradiction. Okay. Woo! Yep. Whoa. 1 through 20. I have one more line. Oh yeah. That's because on my paper I just didn't do, well anyway, it doesn't matter. Okay, good. That was a little bit choppy, but okay, the handwriting is extremely clear, and I think the explanation of the big idea was really clear too, and okay, that was number 3. Number 4 I'm not going to do. And after this, we're going to have a quiz on Fitch-style proofs and predicate logic, and then we're going to do sort of 2 more Fitch-style proofs, ever. That'll be it. Okay, goodbye.